Organizations often struggle to have a clear understanding of core business entities like customers, products, suppliers, and parts. Due to missing data, due to lack of common identifiers, due to typographical and other variations that happen across different systems. So today in this demo, we are going to look at an AI/ML based approach directly working on Databricks on data which resides direct on the Databricks environment directly as part of the data lake, and see how easy it is to configure a workflow to resolve these identities. We've already configured the Zingg API on this cluster, and we are going to go ahead and start building the Zingg program, which is a Python-based program and can be used directly within Databricks. So let us define our input, which is a CSV file saved within our data lake and has customer information like first name, last name, street, and other information. Now we want to match this data. So we want to define what attributes we care to match on and how. We define the match types to be fuzzy, exact, and a lot of other options are also available in terms of numeric, in terms of email. And fuzzy essentially would be, more tolerant to variations. And there are different kinds of match types available depending on the kind of data that you have. So these are the ones that we want to match on. Pretty much we've chosen almost all attributes within our input. Now let's go ahead and find some pairs for user labeling. Now we want to make sure that we're not actually doing any rules. We don't have to tweak any algorithms and run a pure AI/ML based system. And for that, some training data is needed. So we get Zingg to find some records which the user can label. And through that, Zingg can internally create rules or algorithms and select the best hyperparameters to tune those algorithms to give us the best matches. Now to understand, for Zingg to understand really what we want to match on and how, we've configured the fields, but we also need to tell it, what really is a match for us. A match could be different in a person setting, it could be different in a household setting, and that's what we have to train the system to. So let's actually, Zingg has already found some pairs for us, and let's see if we, if we can make it match. So here it has found, this record. And yes, it looks like a match. So let us get Zingg to understand that this is a match by pressing on match. And every interaction that we have with Zingg like this will help in creating the models which will understand what is the kind of matching we want, what is attribute that is more important to us, and things like that. No, this is not a match. This is a match. And that's pretty much the crux of, training Zingg, that we say what is a match, what is not a match in our context. And the models internally are created. These models understand field level and record level similarity based on what we are training it to. And they also understand and learn how not to match every record with every other record and to be able to compute the matching in a decent time. So we've done some labeling and, let's just save these. So now let's go ahead and look at the output data. To every input record, Zingg adds 3 distinct columns: the minimum and the maximum score and the cluster ID. Matching records get the same cluster ID, whereas the scores indicate how well that record has matched with other records in the same cluster. So if we look at this, we have this record which has matched very well, and there were pretty much not a lot of differences for Brooklyn, except that the date of birth was missing. In the case of Keziah, we see that there were variations in the street, and yet it has matched. And that's pretty much how the Zingg matching would work.